Hello all. So I am Vivek Singh and I am going to talk something about rags to riches. So first of all, this name rags to riches might come off a little funny to you all, but I'll explain it to you one by one how it will go about. So whenever we try to build an AI application, these are some of the phases that we usually have, right? Because we don't know what exactly is the direct way to go about it. Unlike a software engineering project wherein we first of all document an API, then code and then deploy, these are some of the things that are pretty standard there, but we can't have the similar thing when we want to build a data science product, right? So I'll try to create more like a mental model for you all in such a way that you can create your application along with testing. It all started last year when everyone was in the hackathon mood. Everyone was innovating around some GPT models I could see, and there were some wrappers built around it. Now, in the month of September, there was a AI hackathon, if I remember correctly. Me and my team built something called AI DXP, which was something like if we have some prompts and then we type enter, the content stack will be taking some care of it. Something like this. Now, once this was done, in the month of November, we had AI DevFest, just a normal DevFest. We built visual search, wherein if we write a text query, something like an olive green wearing guy, handsome guy, with some paneer chutney on his left thigh, my photo needs to be recommended. The result of both of these hackathons was pretty clear that we lost. So I was not satisfied with this, and I went to the secret agent of our content stack because I wanted to seek some feedback. Now, this guy, which I'm talking about, I just kidnapped him for some time and asked him what was exactly wrong with our application. This. Now, this guy told us that your application was very good, but there was something flawed in it. And let us see what the verdict was. Too complex to understand. Again, I was not satisfied with this. I went back to my teammates with whom I built the visual search and explained the entire backend to them. Now that I reiterated the entire system design or everything to them, I just asked them, how are they planning to explain it to me? Their reaction was something like this. Yes, this was a surprise to me. Thank you. So I decided, yes, we need a model or a framework which we can use to build any application effectively. So a framework starts with first thinking, second black box, third validation. With a combination of these three, I'm pretty sure you can build something more like this. Now, let us move on to the first stage, which is the thinking one. Can I just say thinking is adding a feature to your problem? More like adding a dimension to your problem? Now, I will give more information about this. Let us imagine a nature's picture, okay? If I say I want you to describe this picture, what kind of attributes will you be taking? Contrast, hue, saturation point, and all that. Now, would that be sufficient enough to capture your image? Maybe not, maybe. So, what can be the next solution? Just use more number of dimensions. Simple solution, right? Just incorporate everything that was in the image. Is that a good thing? Let us see. Is overthinking good? Just a question to a normal audience. I hope I get the right answer this time. It's just a Boolean value. Okay, some of them are nodding yes. Very good. The real answer is yes. Or I would say overthinking will lead you to some generalization. Because something that has not happened, you will generalize it to a normal audience as well. Hence, overthinking is bad. Now let us take an example to understand this even better. Now, imagine I want to train an image classifier of this famous person. And I train my image with this image and with this image. Now, imagine I have two vectorizers that will basically differentiate, which have one of them has, let's say, 3 features, and the one has more than 3 features. Consider these ones. Yeah. So first of them considers about eye shape, nose shape, and some eyebrow. And the next one is like a whole list, wherein I used a lot of features, lot of dimensions. Now I train a model, and as we concluded, that overthinking might not be the best approach, right? So here also, the model will not be able to perform good. Why? Because the model will fail for the following images. Sorry, Virat Kohli fans. Or here as well. Why? Because you have considered beard length, beard width, and everything, due to which your model has generalized to some truths, and due to which your model will not be able to identify the real aspect of Virat Kohli. Now let us take a practical example. You were able to see Virat Kohli very nicely in, let's say, this one. Are you still able to identify Virat Kohli? I'm pretty sure most of us will be, right? Because you don't need the entire image. Similarly, a model will not need an entire image. Now, these were some of the dimensions that we worked upon in our DevFest as well as the AIDXP. The most famous one is the OpenAI, which has some 1536 dimensions, BG large, BG small, and the Clip one. Clip one is a very special one to us because it was used during the DevFest and it consisted of more than 786 dimensions. And BERT encoder. This is for the magic trick. I'll save it for the future. This has some 512 dimensions. Now, in the DevFest, we had an image of this guy. I'm sure you might know him. I'm sure you don't. I don't care. So, the first dimension has the first encoder had some 4,000 dimensions, and the time it took was close to 1.2 seconds. Now, when we were experimenting, we reduced the dimensions or the thinking capability to 768, and there was a drastic difference of 237 milliseconds. This is very important to understand because your AI model is not the sole thing in your project. There are several other handshakes that will be happening in the background as well, and reducing time with reducing dimension is a key tool in it. So now we have established that dimensionality is the first part of the framework. Okay, so let us move on to the next part. Black box. Okay, so this is the second part. What is the first thing that comes into your mind when you say black box? It is simply when you give in some input and something happens, some magic happens, and some output is given out, right? This is something that most of us generalize it. There is also one more reason, but I'll get back to it in the further slides. Let's consider this image again and pass it through an image model. Let's assume that is an image model, a classifier. It will give us Virat Kohli. Now imagine if I give it to some Gen AI like ChatGPT and some vector DB stuff. It will give it Virat Kohli is a great Indian cricketer, behind MS Dhoni, of course, sorry. Similarly, for object detection, it will give out ears, eyes, and so on. Now, when I say that there are two reasons I call it black box, the first reason was that we don't know what is the input, we only care about the output. The next thing was, imagine this is a black box you have. We take a small section out of it, and we zoom it. Some AI models that you can use in this black box is this much. Now just imagine, there are so many models, such as this. Which one to use? This is a new problem, right? To circumvent this issue, there is one more beautiful magic that is called leaderboard. There is a website, if you can see it, I'm not sure, but there is a website that is called MTEB leaderboard, wherein you can just go to there, see whether you can find your model, their dimensions, and how you can tune it. It consists of everything of your purposes, that is from classification, regression, and so on. Similarly, for image classification, there are several other models depending on your requirements, because there is no one size that fits all, right? So depending on your requirements, you can just tweak it. Now, this was done with the black box. Let us move to the third stage, that is the validation. To understand validation, let us play a card game. So, first of all, I would like to get invited to Vasu's birthday party as a magician. To do so, I will have to convince him, right? Whether I can be the suitable audience for that. Now, let us play a trick. I say, Vasu, I am shuffling a deck of cards, and I tell him that, okay, just choose one. Now, and obviously I will not be seeing that, and he'll just show it to the audience. And if I say, hey Vasu, that your color is red, so would he be surprised? Probably not, right? Because there are like 26 cards out of the total deck of 52. The probability of me guessing anything was close to 50%, right? Similarly, if I just say that it is diamond red color, now Vasu might be taking some interest and will say, okay, tell me more about it. Because now the probability of me guessing something has reduced, which is now currently 0.25. Now, if I say something like, okay, it is 4 of red of diamond, then I'm pretty sure everyone will be blown, and due to which the probability of happening that is 1 by 52. Why did I tell this story? All of this comes back to the null hypothesis. Let me explain it to you what it is. Well, whenever you train a model and you get an output, you want to know whether you can productionize it as well, right? So to do that, we usually take a probability of guessing by chance. When I say probability of guessing, is your model even predicting something, or has it learned something, or is it just going in the random direction? To understand that, we do a null hypothesis or hypothesis testing check, wherein we get the value of 0.02 as in the previous slide here. The industry standard, again, is 0.05. And if we are like getting lesser than 0.05, we can say that it has met the industry standard, and we can give it out to the user as well. Now, with this, we have validated our model, and we can take it to the end user. With the combination of these three steps, wherein we first identify the correct dimension, identify the correct model, and then finally validate our results, we can go to the customer or consumer that, hey, we have a good model, just try it out. So with this, the framework is done. Thank you all.